Hello, all right. So TwoTails, a Scala compiler plugin. Originally when I submitted, I had this as TwoTails for the price of one, but tried to put this on the screen and it really didn't fit. So my name is Owein Reese. I'm from New York. I work at a company called MediaMath. We're an ad tech, good company. The things we do are basically all in Scala. We do ad validation, so you don't get malware. Classifications for making sure Viagra doesn't appear on Disney. And then we do ad serving too. So I think global aggregate at peak about 1.7 million requests a second with under 10 milliseconds of latency. So that's the kind of stuff we do. It's a good company because they sent me down here. They paid for my flight. They paid for my hotel room. And this is something that I work on my own time. This is my hobby. And I'm not hiring. So keep that in mind when I am hiring. All right, cool. So this talk, I'm going to talk about this plugin, why you should care about mutual recursion, how to use this plugin, why this language feature was probably not put into the library or to the language itself in the beginning, and my efforts to sort of see if I can get to the place or a point where eventually I can actually try and propose this to these guys and say, hey, let's add this in. So who actually knows what mutual recursion is or is familiar with the concept? All right, cool. So there's some of you. Tail recursion. We've all seen this annotation. It's a nice annotation. You put it in, you write your function. If it's not actually tail recursive, oh good, you can see it. It'll throw a compiler error. And the reason it does this, or what it's really looking for, is this count function. This count function's in what they call tail call position. So in other words, there's no 1 plus or 2 times or something. It is the very last call. The value that is returned out of that count is actually the value that is returned from the call itself. So it goes right through. So you actually create a looping construction here without having to explicitly write a looping. Mutual recursion. So I have a function 1. It depends on 2 in tail call. 2 depends on 1, again, in tail call. And this object is aptly named overflow because if I try and put in a value like 76,000, which is over 65,000, whatever, I can never remember this, so 76,000. I get happy days. This is awesome because the previous stuff will compile and then I'll get mud in my eye at runtime. So that's really awesome. I love that. So here's the same code, except I changed the object name and I added some annotations. And of course, I'm using my compiler plugin. And I put in 76,000, I get 76,001. So that's pretty cool. I wrote 2 functions, added a compiler plugin, some annotations, and all I did was add 1 to something. Yeah. So why should you use this? All right, so I'm going to try and appeal to 2 groups here. First is mutual recursion right now, the way you do it in Scala is you use this thing called a trampoline. It's a data structure. If you are familiar with Scala Z or CATS, you've seen it. They do it through a free monad. It essentially is something where you trade stack for heap. In other words, I do a lot of little allocations. Every single loop, I'm doing an allocation. Actually, more than one allocation. And if you are dealing with a situation where performance matters, where you cannot suffer that GC pressure like you have 10 milliseconds or less of latency, you can't use these things, which is a real shame because, me personally, I think in terms of recursion, this is sort of how the thought process in my brain works. So that's kind of the way I want to write code. The other way is probably some more or broader context of view is tail rec. It's pretty cool. But if I want to keep that tail recursion going, and the business users start throwing more and more business logic at me, these functions tend to grow some warts, and you start trying to work around those warts while keeping your tail recursion. That sucks. You wind up with like a 400-line function. If you come up to me smiling all happy and ask me to code review a 400-line function, I'm going to smile right back at you and think, wow, your face would look better with my fist in it. So this allows you to break up those functions into more meaningful chunks where I can look at that and I can read about it and I can think about them and reason what each individual piece is doing. I can actually name them some better or more appropriate things like, I don't know, inner loop or replace, because I'm doing something with stuff. So that's really the sales pitch for this thing. And so if I do want to use this, if I've sold you already, hopefully, it's simply adding 2 lines to your dependencies. You're going to add a compiler plugin because it will add a new phase. Rob asked me, did I try doing this with macros? The answer is yes. So a compiler plugin is what actually got to work. Sorry. My type signatures. So if you are going to use this, they're going to match. Technically, in the grand scheme of things, that is not required, but in my library it is, and that's for my sanity. So even though these 2 things are mutually recursive, this will actually do a compiler error because the type signatures are different and there's nothing there recursive on. I will look at your call graph. So 1 and 2 call each other, so they're a group, and I will group them together. 3 and 4 call each other, they're a group, I will group them together. Even if these 2 things had the same type signature, I would still group them separately under the hood, and that's actually, I'll tell you why later, but that's something to work over details working with the JVM. Effectively final. If you use tailrec, it doesn't actually need final. You just need to prove to the compiler that nothing overwrites the method. Same way with me. I don't care. And like tailrec, I can put it anywhere. I can embed it in a def, within a def. I can put it on package level. I can't put it on lazy vals. I can't put it on vals. It's got to be defs. And more to the point, it's got to be within the same sort of scoping. So I can't mutually recurse between classes or between a package and a class or things like that. It's got to be sort of self-contained. So how does tailrec work? How does mutual rec work? So let me compare and contrast. So this is your code. You wrote this. This tells you the size of a list because somehow you didn't know to do .size. It's great. Conceptually, it's going to get transformed like this. So you're going to see some bars put in, and you're going to have to see this thing called a label. In Java, you can actually do labels. The JVM allows you to do labels. And if you go in and you look at the spec, they very eloquently and very broad strokes tell you this is not a go-to. See, we attached all these rules. It's a go-to. That's what's happening here. You go to that label, it skips over the label. If the list is nil, returns count. Otherwise, it does this thing, and it goes to count. That's what's happening. It's wonderful. Mutual recursion, we run into this problem where labels are rigid. That's a nice way of saying that I can label this underscore foo and I can label this underscore bar, but from within foo itself, I can't jump to bar. And if you think about this, this makes a whole lot of sense because I'm coming in right into the middle of the definition of bar, so I haven't actually set X. So Y would probably be a null pointer. But if you think even lower level, I haven't even allocated Y onto the stack. It doesn't even exist. So I get into all sorts of problems that I would see in like C, and this is Java or a JVM, and we don't want to see those things. So you're not allowed to do this. And that forces me to actually write a secondary function. So I sort of have to punt on this. I do a transformation. So this plugin is actually code rewriting, and it's rewriting it under the scenes. And hopefully you never have to see it or know about it or really think about it. But that's okay because it turns out that tailrec is the same way. It actually is transforming your code. You probably know it's doing this, but you've never really thought about doing it. And this part is this is awesome. Like, I didn't even know this was existing or happening or anything else like that until I started trying to use and make sure that things worked the way they did. So if you've never actually tried to dick around with the compiler or write a plugin, this is a way of printing the position of each little part of your code. And what that means is, think about this. You write Scala code, so .scala. It's great. It's in a file, right? How does the compiler know to tell you that the compilation error is here? Well, maybe that makes sense if you think about it like, oh, I'm in compilation stage. Okay, yeah, I mean, you know exactly where you are. But there's actually a lot of phases of the compiler, and it moves things along, and it does things, and somehow it's still able at each stage to come back and say, like, no, you screwed up there. That's where the problem is. But at runtime, when an exception is thrown, it can tell you what line of your file the exception was at. And remember, it's taking your Scala code and transforming it into Java bytecode. So it's like a far removed and totally and completely different representation of the code that you wrote down. And they do some really interesting and nice stuff when they do this, because they are annotating where the position is, they can switch things around. They can move things. So when they do this sort of transformation, you can see, like, here's 1042, and that's happening before I get to 594. And you're seeing these things called no position. That's where they're adding, like, synthetic things in there. For instance, if you ever wondered how they do a default parameter, it's actually a synthetic function, and then they check to see if you've added it, or they call this function. And that's it. So I mean, things that they're doing to sort of work around, like, JVM limitations. So I was very happy about 2 weeks ago when I finally got this working. I can finally return your exceptions at pretty much the same line number that they should be. And I'm very happy to see that, but I do, because I'm writing a secondary function, do this like mutual recursion. You will actually see some of it creep through under the hood. You'll see this mutual rec underscore FN $, and some number. So you will see that. I'm hoping that the line numbers stay right. If you do use this, please use this plugin. And you see something different, let me know, because this has been, sort of an area that I've been very hard focused on trying to get right. For those that do use SBT MIMA, I haven't tried to actually make some sort of guarantees between versions, so you can talk to me at some other point. And then we talked about this grouping, like the call graph grouping. So this is, I think, from the Java spec, talking about the JVM. And what they're saying is there's a bug. There was some arbitrary byte limitation that they added to method sizes. And normally you guys don't care about that, right? Like, most of the time when you write code, this isn't even a thought, and you might have seen it. But actually, has anyone actually run into your method size or your function is too large here? Show of hands. 1, 2, 3, 4. 4 guys. All right. Awesome. So I'm using the secondary function. Guess what I'm doing? I'm taking all your other functions and I'm cramming it in there. So even though, like, it's actually kind of hard to get there, I might actually do it. And so this is something that I want to work on, and I have an idea of how to do it. Actually, I just need to go out and do it. But the problem is, finale, about 2 weeks ago, right before I was about to release 020, some guy said, hey, I tried doing this. It failed. So now I've got a little mud in my eye. This is like when you're working the compiler, I don't know. I mean, this is like 10 things down, something called an explicit outer phase. I had no idea that even existed. But an exception happens there, and I was looking at Scala days, and I'm trying to show Adrian my code, and he's like, everything looks good. And he's like, I don't see anything obviously wrong. So I learned how to actually debug the compiler itself, look at all the symbols, look at all the trees, look at all the positions, and I couldn't see anything wrong. And then this happened, and I still can't see anything wrong. So either there's a bug in the compiler that none of us has ever hit, that's never really been a bug because no one's tripped over it until me, or I've done something really wrong. And I'm hoping I've done something really wrong, but I don't know. So the part I'm working on right now, the part that's going to happen in 030, is I'm going to try and get rid of the tail rec. So that mutual rec function that I'm working, I'm cheating. I'm using tail rec in it because it has these really nice error messages when you don't do something in tail recursive format. And I'm going to have to not use it, not abuse it, to see if this thing goes away, because the way I'm having to do it invites some other issues in the pattern matching phase, which was it you, Daniel? Yeah, last night you were saying like 80% of the type checker is embedded in the pattern matching phase. Repeatedly redundant. Yeah, that's great. So not only do I use the pattern matching phase, but I also use tail rec all at the same time. And yeah, that's going to be fun. So I got to get rid of this. But if you want to look at the code, it's at Wheaties TwoTails. It's right now the master branch should be about 270 lines of code. That's it. That's really all it took to sort of add this in. And this has been months of effort for me. Like it may not look like it, but like a single line with like set type this was actually like 4 weeks of me just banging my head against stuff until I finally just tried something or saw something and then said, oh man, maybe this will work. And again, if you want to add it to your code, please do. Yes, I just showed a really awful bug up there. But there could be other really awful bugs up there, and I would really like to know where they are. So for the simple cases, some simple cyclic cases where it's always return or go to the next step, it works. But I guarantee you in the future, it will not be limited to just that. So thank you all. My name's Owen. That's my Twitter handle.